Hi folks, Joseph Kursky here with you to talk about geospatial data, how to find it, how to assess it, how to teach about it, and why it all matters. Thanks for being with me. The purpose of this presentation is to do four things: empower you with skills to find geospatial data for your teaching, your research, or your project. Number two, to enable you to be able to make wise, smart decisions about whether your data is appropriate for your needs. Number three, provide you with resources to teach societal issues surrounding data, such as location privacy, data quality, copyright, and ethics. And fourth, connect you with and to available ESRI resources for support and further learning. Let's get started. Now, admittedly, data is a topic that it can seem a bit dry and boring, right? However, I submit to you all that it is key to GIS, to instruction, to empowering students and colleagues to be change agents in their communities and in their world, no matter what profession they go into. Data is a key component of GIS. It always has been from the inception of GIS back in the 1960s. GIS contains software, increasingly in the cloud, software as a service, information products, data, spatial data, location-based data, hardware, people, and procedures or a process or methods. Geospatial data, as a reminder, has some important characteristics. This is not an all-encompassing list, but it's tied to location. It's got a street address, a latitude, longitude, a place name, something that ties it to a location. Now, that location could be on, above, or below the surface of the Earth. It could be in the oceans. It could be on Mars. It has to do with a location. It's often combined with attribute information, the water quality, the population of a place, the demographics of a place, the characteristics of the biome, etc. It often contains a temporal component, a time component, and it can be generated in a widening variety of ways. Crowdsourced surveys, for example, from Survey 123 or Quick Capture, machine learning or artificial intelligence techniques, feeds from the Internet of Things, traffic cams, stream gauges, etc., UAVs or drones and other expanding remote sensing techniques and platforms, unstructured data, a PDF, for example, tabular data, and much more. There are an expanding array of geospatial data sources as well. Tables and spreadsheets, field surveys, field observations, even notes, imagery from aircraft, UAVs, satellites, grids, tiles, GeoJSON, and other widening, expanding sets of formats, shapefiles, geodatabases, ground photographs, IoT feeds, again, stream gauges, traffic cams, sensors of all kinds, augmented reality, 2D and 3D maps and visualizations, and many more sources for geospatial data. I won't go into the extensive history behind geospatial data, but in short, geospatial data didn't just appear overnight. In the early days of GIS, geospatial data was created from the paper or analog aerial photos, topographic maps, census demographic maps, etc. Now GIS is actually used to generate any sort of media-based, paper-based items, which are increasingly fewer and farther between as people want to consume the digital information. But geospatial data has a long history going back to the analog paper mapping and surveying days. That provided the foundation for some of geospatial data, especially in the early days of GIS from the 1960s to about 2000. And since then, these expanding platforms, sensors, etc., ways of generating geospatial data have far outstripped anything that we did in the analog days of mapping. But in the past, it was very difficult to store geospatial data, serve that data, find that data, and access that data. In the early days of GIS, once again, it was all on physical media, magnetic tape, disks, and other means. Now with the web, that has of course greatly expanded the array, the variety, the volume, as we'll see, of geospatial data. But it was difficult in the old days for data providers to serve the data and for data users to access the data. Today, geospatial data, no surprise to you all listening to this, I'm sure, but is offered with a greater variety, volume, and accessibility than ever before. There's no shortage of data nowadays, folks. It also frequently includes a temporal aspect. You can access it on any device more and more frequently, anywhere, anytime, by anyone. It's truly an amazing world that we're living in, but it also has important implications for our decision making and our instruction. Today, geospatial data can be accessed as downloadable files, which has been the case for decades, and increasingly nowadays as streaming services, data as a service. Data as services is an enormous leap forward in many ways. We'll talk about a few of those in this presentation. Here on this slide, you can see some of the ways that geospatial data is being served. Let's discuss two examples of the traditional way of obtaining data versus today's streaming and other methods. First, census demographics. The traditional ways are still with us and will be with us for some data sets for the foreseeable future. But where these new methods that I'll describe exist, use them. Use the streaming methods. Faster, more reliable updates in near real time or real time makes your life a lot easier to consume data. The traditional method in this example is that, let's say you wanted to obtain some demographic data for the US. You would go to the Census Bureau's Tiger files, which have the geometry for census tracts, block groups, counties, political and statistical areas. You'd have to then get the tables of the demographic data and join them to the Tiger files, to the geometry, and then have to deal with things like field names are very difficult to determine. P001-0001 is total population. P001-0002 is median age, etc. You'd have to deal with all of that, and it was a long multi-step process. It still is. It only works for one level of geography at a time, census tract, block groups, zip codes, etc. The data also is static. You have to keep doing this process, keep downloading this process for updated data. And you have to repeat it for different countries if you want to do this in another country besides the US. And it's also very much tied to desktop GIS. The new method in this particular example is you stream the demographics from ArcGIS Living Atlas of the world directly into your GIS project, whether it's in ArcGIS Online or ArcGIS Pro. So you've got multiple software that it works with. It works for many countries around the world. The data often updates automatically. It's multi-scale, so as you zoom in, you see the census tracts and then the block groups, for example, and zoom out, you see census tracts and zip codes and counties as a US example. There's no processing of the data. There's no dealing with attributes that don't make any sense that you have to translate the field names. And it reduces the data acquisition time from hours to literally minutes. Now, let's say someone says, but Joseph, those long multi-step processes built some skills in students. Admittedly true. But I would submit to you all that there are more efficient ways to building some of those skills, like joining tables, for example. I personally can relate. I found it difficult to give up my carefully prepared 40-page census Tiger lessons that I had created over the years, and you probably did the same thing. But I needed to. Plus, graduates in the workplace are very seldom going to be asked to go through these traditional methods much longer. Now let's examine an elevation example. The traditional method of obtaining elevation data is you'd go to nationalmap.gov or some other portal. You'd download that data to your GIS software. You'd create your hillshades, your slopes, your aspects, and other derivative products in your GIS software. The disadvantages to that method is that it was a long process to download individual blocks, sometimes 7.5-minute tiles, of terrain data. And then you'd have to create the products one at a time. Then you'd have to join them all together or stitch them all together. You might have edge matching issues, etc. It's also tied to desktop GIS. And you'd have to repeat it for multiple areas or even multiple countries outside the US. The new method is you stream the elevation service from ArcGIS Living Atlas of the World, once again, starting to sound familiar, directly to your GIS project. Advantages there: reduces the data acquisition time from hours to minutes, no processing of the data required, no edges to match. You can stream the data to match the boundaries of your watershed or your county or your other area of study. You can use it in ArcGIS Online as well as ArcGIS Pro. It's multi-scale. Derivative products also are sometimes available as services. In other words, the hillshades, the aspects, the slope, those are oftentimes services as well. And some of these data sets are global. I'd like to emphasize here that these windows into the future, which are actually present-day realities, are an indication to me that this is just the beginning. In other words, this new method of accessing data, we're just at the beginning stages, folks. Now, one could argue that geospatial data was always big data, for example, as the GIS community has always been keen on accessing and using large amounts of vector and raster data. Yeah, more data. But truly big geospatial data is starting to arrive. Now, working with these very large data sets requires data warehousing, distributed computing, analytics in the cloud, libraries and binaries, and tools such as the Esri Geospatial Cloud, GeoEvent Server, ArcGIS GeoAnalytics Server, ArcGIS Image Server, and other enterprise solutions. And this will require people who understand GIS analytics, but also from a systems perspective and with web tools. Now, people who embrace this, they're going to need some different GIS skills, which will build on what we've done so far, but how do we teach those skills? How can we embrace this? I would recommend starting small. For example, start with the Microsoft Buildings layer for the USA. It's got millions of buildings in it, and you can start analyzing it in ArcGIS Online and in ArcGIS Pro. So starts with something that's doable, but it touches on this big data world. And for more, see this Esri article on real-time big data analytics. This could be a whole presentation by itself, but I just wanted to get you thinking about the coming avalanche of requirements and truly big data in the geospatial world. Data skills are in high demand in GIS-related positions, but also in non-GIS positions alike, in a wide variety from anthropology to zoology, A to Z. Big data skills are in high demand. Be purposeful about teaching with and about data. More about this in a bit, but this is a key part of the skills you are building in students. This is from a job posting of a GIS specialist in landscape biology and ecology on geosearch.com, December 2021. Notice this is just a section of the job posting. Notice all the data references. This is just one of hundreds of jobs that are focused on solving problems, but they require people to be adept, skilled, cognizant, aware of how to work with data. What data skills are in demand? Here are just a few of them. Scan this for a moment and see that it ranges from generating to curating. Gosh, with the GIS cloud, you put data out there in the cloud, you're going to have to curate it. You've got to maintain it. You can't just put it up there and just let it sit for lots of reasons. We have a dynamic planet, this planet Earth. We've got to understand the planet and all of its multifaceted systems and cycles, the hydrologic cycle, the carbon cycle, and the spheres, the anthrosphere, the hydrosphere, the lithosphere, the biosphere, etc. So spheres, systems, and cycles. We've got to understand all that. The system of systems is really what the Earth is, and that's what geospatial technology is also, a system of systems. So data is central to understanding the world, and these skills are highly in demand, and will continue to be so. Indeed, data science, as I'm sure many of you are aware, has emerged in the job market and is also offered as a discipline, a degree program, a certificate in many university and college programs. These are just a few right here, but there are hundreds of these that have appeared over the last few years. Even in high schools, some data science courses. Using a variety of data, and I'll have more teaching tips in a bit, but it makes your educational program, whatever discipline you happen to be teaching in, vibrant, interesting, and relevant to a wider diversity of students. So keep that variety of data that you're having students analyze in a variety of ways, diverse, multi-scale, maybe touching on some key issues of our 21st century world. Population change, biodiversity loss, climate, energy, water, etc. The UN Sustainable Development Goals, for example. Keeping that data of a wide variety will help your program and help your students. I think it's important at this point to talk about what is a modern GIS. A modern GIS is anchored in this geospatial cloud. It's a system of systems. It includes software, apps, such as dashboards, story maps, web app builder apps, experience builder apps, information products, communicating about a geospatially related problem or issue. Data, as we're talking about right now, hardware, people, and a process. Data is central to modern GIS workflows and the whole technology that is modern web-based GIS. Data is not a component of modern GIS. It is really central to all of it. The process, the structure, the infrastructure of the paradigm, the idea of modern GIS. Data is central to all of it, how it's served, how it's accessed, how it's assessed, etc. Data is also integral to this notion of GIS as a service, or GAS, GIS as a service, cloud-based GIS. The first step is simply getting access to this. So how do you access this cloud-based GIS with a tablet or a browser to access a vast amount of services, data, and applications? And this whole GIS as a service is different. It's got data from the Living Atlas, services, servers from anywhere around the world. They're oftentimes real time. They are based a lot of times on imagery, historical data as well. They also have analytics in this GIS as a service, and they have applications, the ability to quickly configure and share data and results with anyone on any device. Data provides the foundation for GIS and this geographic approach. The geographic approach, looking at the world in a holistic, geospatial way, solving problems of our modern 21st century world. Accessing the data, as you can see here in the upper right, is so central to it. How do you visualize and map things if you don't have the data to begin with? The data is the starting point, and often, as I'll talk about later on, a way of keeping your inquiry going, because you ask different questions and new questions and tweak your existing questions, and then you have to acquire oftentimes data to answer those questions. Ultimately, this leads to action. Now, we're not doing this GIS activity for just gaining more head knowledge. We're trying to make smarter, wiser, more sustainable decisions so we can build a happier, more resilient, more equitable world. That is the whole purpose of GIS, to understand our complex planet and to take action to make it a better place for everyone. I would also submit to you all that data enables this holistic, interdisciplinary view that is needed. Specialization is good. We need people that understand soil and energy and water and biomes and population demographics, etc. But we also need people that have that understand a holistic view of the world, and if you adjust one variable, other things on the planet, under the planet, over the planet, etc., and the people that are living on that planet are affected. So how do we make smart decisions so that we're reducing the harmful side effects, but we are augmenting the positive effects? So this data is central to our geographic approach and our geographic understanding of how the world works and should work, and how we want the world to be. Data enables GIS as this common language for solving problems. One could argue that in some ways music is a common language of the world, but there's lots of different kinds of music and people like different kinds of music, etc. Geospatial maps and map-based understandings, spatial understandings, can be our common language for solving problems. And indeed, there are hundreds of case studies out there showing how organizations have come together to solve problems around this approach, seeing the world as one single ecosystem. And data, again, enables that to happen. Some of you may recognize this. Data has always been important to spatial analysis. This is the John Snow cholera map from 1854. John Snow was a very data-centric person, said, I'm going to map the cholera cases, which unfortunately almost always led to death then, in Soho and London on a map. Is there any relationship between the public water pumps and those cholera deaths? So using maps as analytical tools, not just maps as a reference document. Where is Soho? Where is Shanghai? Where is Rio de Janeiro? Using maps as analytical tools is what we're focused on here. And to do that, we have to have maps tied to data in order for all those analytics to run. And also, today, everyone is not just a data consumer, as in the past. In the past, only certain organizations could make geospatial data, mapping agencies, science agencies, because they had the equipment and the knowledge to do it. Nowadays, everyone is a potential data creator through a variety of ways, through web-based GIS. This has huge implications of everyone being a potential data creator. We're going to dig into some of those here in this presentation. But I wanted to show you this map because it shows that data has always been central to map-based spatial thinking. Let's get practical now. How can you find data in this modern GIS era? Here are some challenges. Data needs are often very specialized in theme, scale, region, attributes, and other characteristics. Because projects and problems have certain specifications, certain paradigms, certain boundaries. Often it is difficult to find a similar need by someone else online, so it's hard to find their workflow, their problem that they tried to solve, and how they grappled with data to do it. Third, the ephemeral nature of the web, things being temporary, discussion boards, etc., it makes it challenging to learn from other strategies. Despite the challenges, though, here are some amazing things enabling data at your fingertips, data at your fingertips. First, data are increasingly collected and available in a wider variety of formats and, as I indicated earlier, as services. Second, data is increasingly being seen by organizations, nonprofits, government agencies, academia, private companies as an asset, not as something to charge for and kind of hold near and dear, but to serve for the benefit of all decision makers. And third, open data portal technology such as ArcGIS Hub makes it easier for organizations to serve and curate data. In the past, again, it was difficult for them to do that, but these advances in tools and technologies such as Hub enable them to do it. The benefit for you and I as data consumers is that we've got those Hub sites available and other data portals. Just as there is often no single best source for one specific topic on the web, no single geospatial goldmine exists. I wanted to tell you that right up front here. That is the end-all site for spatial data. I actually, though, think that this is a good thing. Why? Because it forces data users to think critically about the data sets and the choices that they need to make. As I make clear on our Spatial Reserves data blog, choices abound. Those choices require the user to investigate and evaluate each of those data sources, determining fitness for use, which we'll talk about in a moment. Geospatial One-Stop and Data.gov were attempts in the USA to create a one-stop shop for data. Data.gov still exists and is useful. There were collaboration challenges in setting these up and other one-stop shops. Now, as we will see, the ArcGIS Living Atlas of the world is, in my view, the closest thing to a one-stop shop. Over 8,000 curated Living Atlas data layers, maps, and apps. I thought it would be helpful to share some words of advice. Minimize the search time for geospatial data so that you will have maximized the time available for your data analysis. However, don't shortchange your data searching by choosing only the data sets that are easy to obtain. Best available data, bad data, BAD, best available data is oftentimes referred to as bad data. In other words, data that's easy to obtain and you get it right that and you don't really think about what other sources might be around. Remember, all of your decisions will be based on the quality of the data that you acquire. So data quality matters, spending some time acquiring, assessing matters. Also, consider the software you are using and seek to minimize the amount of data conversion that you will have to do. Another reason to use the Living Atlas of the world if you're using Esri software. Let's discuss specific strategies that could be important no matter what data you are seeking to find and use. More data is not always better, okay? That is the bottom line of this slide, and I'm going to return to this in a minute. But first of all, have a clear vision of the data you need, the scale, the date or dates, the extent, the resolution, and other characteristics before you spend time just sort of plunging in and searching. Just like when you go in the field, you have the equipment, you have the units that you're going to use, the data you're going to collect, you have a plan. So same thing with data. Don't just plunge in. Have a clear vision of what you need and what will satisfy your project requirements. Also set a limit on how much time you will devote to searching and processing before the analysis stage. Otherwise, it's sort of like the ether. A data search can consume all of your project's available time. And again, more data is not always better. Do you really need 30 centimeter imagery for your regional study? Do you need higher resolution, more attributes, more layers? Not always. Focus on the data you need to get the job done. As we continue with my advice on strategy, number 2, when you find a potential data source, examine it carefully so that you can decide if and how to use it. To help you decide, there is this graphical aid to assist in deciding whether data can be used, and also this set of 30 checks for data quality in a potential source. I recommend to start searching with the Living Atlas, the ArcGIS Living Atlas of the world, for a variety of reasons that I'll explain in a moment. It is the closest thing to a one-stop shop. Now, why do this? First of all, the content. 8,000 curated and living data layers, maps, and apps, served in a searchable, easy-to-find way, with little thumbnails, metadata, etc. Ease of use. The maps, apps, and data layers are ready for immediate use in ArcGIS Online, ArcGIS Pro, and other applications. Third, the content is rich in metadata. You've got documentation as to who created it, how it was created, what the date was, how often is it updated, why it was created, etc. And it's hosted by authoritative sources: NOAA, USGS, the United Nations Environment Program, nonprofits, academia, local to international government agencies and everything in between, and private companies. Now, living implies two things. Number one, the content is continually being reanalyzed and curated, and the content reflects our dynamic planet Earth. Many of the data layers are updated in real time or near real time: weather, storms, earthquakes, volcanoes, traffic, stream gauges, and much more. Now, if you don't want to save time and effort, by all means, skip the Living Atlas. Haha, just kidding. I would highly recommend stopping here first. Number 4, investigate ArcGIS Hub sites. ArcGIS Hubs have emerged as a viable and easy way for organizations to host data, and as a result, thousands of them exist. What do I mean by them? I mean ArcGIS Hub sites. You can look in the URL, hub.arcgis.com, and that's a hub site. Plus, hub sites usually offer an array of downloading and streaming data options. Starting points include searching your area of interest and then GIS Data Portal or ArcGIS Hub in a Google search, for example. As one of hundreds of examples, here is the Boulder County ArcGIS Hub. There's thousands of examples, actually. There are also useful starting points such as ArcGIS Hub search tools and galleries. Number 5, investigate selected top 10 lists that I've curated, such as top 10 satellite imagery, top 10 Landsat data portals, top 10 vector data portals, in terms of how useful are they on the Spatial Reserves blog. Number 6, investigate portals organized by theme that cover your topic, such as World Resources Institute on land use and natural resources, or the National Renewable Energy Lab's renewable energy data. So whatever your topic is, find organizations that are likely to host that kind of data, and usually they have a GIS or a data node on their websites. Number 7, investigate portals organized by location that would cover at least in part your study area. So location matters. Start with location. If none of these other things that I mentioned earlier are helpful, you're in number 7 now. For example, the Ordnance Survey for the UK, if you've got a UK study, or state, province, region, or city examples here for Oregon. here for a large city, Los Angeles, and here for a small city of Oak Hill, West Virginia. Number 8, use Business Analyst Web as a data source for multiple countries, for hundreds of demographics, business locations, and behavior variables, health, expenditures, lifestyle, and much more. This is a tremendous resource and is oftentimes overlooked if you're not in business. But I'm just here to tell you that no matter what field you're in, you're going to find some treasures in there in terms of data. That's one of the best things about Business Analyst Web. It's online, the data is rich and varied, and it's for multiple countries. And it's also updated and has projections on demographics and other variables into the future as well. Here's some documentation on the data sets that are at your fingertips in Business Analyst Web. Number 9, because an increasing amount of research is tied to geospatial data, I've got a couple of blog posts about this. Research tied to data. Check Google Scholar, library databases, and other sources of peer-reviewed research, as well as conference proceedings from ESRI, the American Geophysical Union, American Association of Geographers, and other major events to investigate those sources identified in the research. Now, be tenacious on this part because there are some inherent challenges with obtaining data tied to scholarly research. This is a relatively new movement. In the past, much research was published and you don't have access, the reader doesn't have access to the data for a variety of reasons that we could talk about. But increasingly, there's pressure on researchers to provide the data so someone can replicate your study in a different area or with different variables, etc. So don't neglect this one, even if it's a bit difficult at the present time. Now, the geographic inquiry process, I would submit, means that data acquisition is iterative. And I hope these previous 9 steps that I've outlined are helpful. But as you go through mining for data, you're, again, going to be going through this process where you're asking a geographic question, you're acquiring the resources, the data that we've been talking about, you're exploring it, you're assessing it, you're analyzing it, you're acting on that knowledge, you're sharing that knowledge with others, and this often leads, it should lead to additional questions along the way, leading to additional data inquiries. This is an iterative process. Let's pick apart how this actually works in practice. Not in huge amount of detail. I've got some words on these slides, and I encourage you to skim these. But let's use a real-world example. I recently received a request from an educator who needed to support a project involving drought in Colorado with these data sets that you see here: moisture, stream flow, precipitation, temperature, agricultural health. What kind of data is available? So I followed my own advice and went through those stages that I outlined for you a moment ago. And my result of my investigation are as follows. I found the Geospatial Centroid at Colorado State University, the Open Colorado Data Catalog, Colorado View, and also portals from different agencies such as the Department of Natural Resources. Now, they required close evaluation to determine if they met the inquirer's needs, but also there was an example of a DNR viewer from the Department of Natural Resources, which does not allow for the downloading of certain kinds of data sets, but another portal from the same agency does. So you need to do some investigation here and some deep dives. On streamflow, for example, from the USGS, one of my favorite resources is this waterdata.usgs.gov. But again, thinking about a new paradigm, it's also a live data feed in ArcGIS Online. And so the advantage there is that you've got it instantly at your fingertips, no processing required, and it's a data feed. On the topic of groundwater, I've found this report and sets of data, reservoirs, Living Atlas of the World as well, but the level of the reservoirs is a bit more difficult to obtain. And this indicates another tip that I have for you all, and that is sometimes the 20th century methods actually result in low-hanging fruit to be plucked, and if you know what I mean. It may involve calling or emailing the agencies themselves. Oftentimes, almost always, people are more than willing to share data. If it's public domain data, and if it's not even on their site, you're an inquirer, email or phone, they'll provide the data for you. Agricultural health, I found some mixed results there. An agricultural stress index from the Food and Agricultural Organization. State Department of Agricultures are good sources. There's also a story map with some links to individual map data layers. So sometimes story maps actually provide some links that are useful, even if it's not a portal like an ArcGIS Hub. Continuing our investigation now on the topic of temperature, I recently worked with an ESRI colleague on the data team, and good news. My colleague created this average global air temperature layer. Very nice. On the topic of precipitation, in conjunction with an educational project, I compiled this layer as well as other Colorado layers, and I display them here in this gallery. The precipitation data came from CocoRa's, one of my favorite data portals. It's been around for 20 plus years. And in terms of water use, this remains challenging, but there's a Living Atlas collection that contains water-related items. And there's also this water use report from the USGS. This might be a good use for LocateXT, where you've got location data inside a document like a PDF. I hope that summary was helpful. Let's talk about something else that's related. How can you know if data is any good? The data quality behind it. There's two tenets that I'd like to bring up here. Fitness for use and truth in labeling. Fitness for use means it is the data user's responsibility to determine whether a data set is fit for their project. Truth in labeling means it is the data producer's responsibility to provide metadata and other information that describes the data accurately. This enables the data user to determine fitness for use. Now remember though, folks, with modern GIS capabilities and ease of publishing data in many different ways, every data user is now a potential data producer. Thus, everyone in GIS needs to pay attention to both fitness for use and truth in labeling. Here are some data quality examples that relate to this question about how can you know if the data is any good. Let's take a look at these images here, for example. Let's take a look at this essay of mine about why data quality still matters now more than ever, with some key examples here. Intentional offsets on web maps. Let's take a look at that. And why does it matter? Here's an example from Lyme disease mapping that a colleague and I did some years back that I think is still incredibly relevant today. Faked satellite imagery? Let's take a look at that for a moment. And finally, here are some tips of mine about teaching about spatial data quality. What really matters here, folks? Be critical of the data. All data. Be critical of it. Recognize its incredible utility, its usefulness in a wide variety of settings and projects. But also recognize that it's limited. Maps are representations of reality. We can't map the world at one-to-one scale. That would be a big web map or GIS data layer, wouldn't it? If we could map it in paper, that would be a huge piece of paper to fold. But the point is, maps are representations of reality, very useful representations, but representations nonetheless. There's generalization, there's map projection issues, there's all kinds of things with our oblate spheroid, right? And getting that into a 2D or a 3D map or GIS database. So be critical of the data, including and perhaps especially mapped data. I think mapped data has this air of authenticity. It's often just believed because it's a map and it looks authoritative. But be critical of it. Remember, anybody can create a map from a GIS nowadays and serve it for millions of people to look at. Be critical of it. Take a look at a couple of these examples. 3,000 degrees in Texas. I know it gets hot in Texas, but this was from a data feed that was online for at least a year before it was taken down and corrected. And also the precipitation rate and humidity and the wind speed are off the scale. The only thing that's normal here is the pressure. But if you weren't critical of it, your interpolated surface of a variety of variables, weather related, would have a big spike at Cleburne, Texas, if you weren't critical of the data. This lower right image was in a catalog, and to the fairness of the publisher, they eventually, after I and a couple of colleagues wrote to them and said, you know, map orientation, the image really does matter here, the way it's oriented. Please fix. And they did. What about this? George Mason University. I thought it was a major research institution. Simple Chinese fast food chain. Why does it say that for the subtitle? Interesting. Also, I know many of these maps are generated for people to click on websites, and some of them are kind of fun, admittedly, but be critical of those as well, even ones that are meant to be funny. What is the end value for some of these things? For example, favorite foods in every state. Oh, you're from Pennsylvania? What's your favorite food? I'll put it on the map. Your office mate is the end value of one. So be critical of those maps as well. For more bad maps, see my presentation here. All data are created in a societal context. A lot more we could say about that. Here are some selected societal issues therefore surrounding data. Location privacy. Should I share my own location? If I want that pizza to be delivered, absolutely. I don't want to just say, well, I'm somewhere in Colorado. I'm going to give my address. Should I share the phenomenon that I am studying? Should I share the location of the people I am studying? What are the implications of doing so? Think about that when you're sharing. Copyright, another huge topic right there. Am I allowed to use the map or image content in my GIS project or my story map for that matter, or a dashboard or other means of communication? Where can I obtain permission to do so if I encounter copyrighted material? What sources can I regularly access that are not copyrighted? My own and also from certain federal agencies in the US, for example. Ethics, another huge topic. How can GIS be used to benefit society and not harm society? What are everyday critical and ethical decisions that I need to make and that you need to make and that we need to make in using GIS? Let's pick apart ethics a bit more. Ethics matter in GIS because, touching on what I said a moment ago, geospatial data are powerful and oft used means of communicating, right? Maps have been used for thousands of years to communicate, of influencing also and making decisions. Data is not created in a vacuum, but rather in a value-laden societal framework. And a couple implications are, first of all, maps are powerful means of communication. So take the responsibility as map author. Everyone is a map author nowadays, seriously. Again, maps have this sort of aura of authenticity. They tend to be believed just because they're a map, especially with all these wonderful cartographic tools. They can look really good. Be thoughtful about the projection, the symbology, the classification methods, and other techniques that you're employing. Do not intentionally mislead your audience. Mark Monmonier's book, How to Lie with Maps, is essential reading here. Due to crowdsourcing and WebGIS, remember, everyone is now a potential map producer, no longer just a map consumer. With a greater number of maps, this means there's a greater variety of maps and purposes than ever before. Again, be thoughtful about the maps and data layers you select for your own purposes. Here's the cartographer's code of ethics. I'm not going to read all these. You can read them, skim them for yourself, but straightforward, know your audience, do not intentionally lie with the data, choose your symbols, your projection, your classification methods wisely. The map should be repeatable, and then also pay attention to different cultural values and principles. This is from a cartography thematic map design book by Dent, Torgerson, and Hodler. There are some deeper dives that we'll go into here for just a few moments. The Cartographer's Code of Ethics I've already mentioned, but the GIS Certification Institute, the people that grant a GISP, also have a code of ethics that I think is very well done and worth looking at. There's also my guidelines, ways to teach about ethics. And there's also some wonderful case studies in ethics from Penn State that I highly encourage you to look at. They're very compelling. They're short and sweet, but very thought-provoking. Here are a few recommendations about teaching about and with data in terms of what we've been talking about. Not too many, just something for you to think about. First, include lessons where students must go to a wide variety of data portals at a variety of different scales and themes. Then they have to practice accessing the data from those portals and dealing with all of the inherent challenges. In other words, don't just package up everything into these nice, tidy lessons and give the students these data sets that are already ready to go and they're all packaged and clean. Make them deal with these uncertainties of some of these data portals and the decisions that they have to make in whether to use or not use some of the data layers on those portals. Include discussions about societal issues surrounding data throughout each course, rather than just kind of saving it for, well, today we're going to talk about societal issues. Weave those discussions in throughout. Include at least a few lessons that are structured such that students face a problem and have to determine, well, where am I going to get the data to solve this problem? So they have to, again, access and process that data and use the data in a problem-solving environment with GIS tools. As I mentioned at the beginning, this data topic can be a bit dry, okay, admittedly, but keep it interesting. These are incredibly relevant topics here for our times. The data discussions can be dry, admittedly, but if you use this gigapixel image, for example, to teach about location privacy, wow, are there any faces that are grayed out or pixelized or pixelated? How many people in a sample of 10 are on their smartphones, and what are the implications there? Include at least one lessons where students have to populate their own metadata. We've got some lessons and some guidelines and some documentation as to how to do that. Include at least one lesson where students are faced with a map or data layer that looks valid and appealing, but it contains very little or no metadata. And then discuss, should the data layer be used? If so, in what context? But I recommend you let the students bring up, hey, there's no metadata, rather than you as the instructor pointing this out. Let them point this out and then deal with it. Well, folks, to sum up, this is an important topic and I hope you agree. Let's talk about how do you continue your learning in this important area. First of all, the Geospatial Data book, blog, and 10 lessons that actually use public domain data and problem-solving scenarios is right here on the spatialreserves.wordpress.com site. It originally came from a Esri Press book that a colleague, Jill Clark, and I wrote, and we continued the discussion with the blog. Second, put data to practical use via lessons in the Learn Lesson library. Do a search on data and some other topics, and you'll be able to dig into this in a practical way. Back on that Spatial Reserves data blog, for high interest, search on everyday examples. That has the IoT feed with the 3200 degree temperature reading in Texas, the George Mason University as a Chinese fast food chain, and also a Beatles album that's not really an album, it's someone's misspelled playlist. But again, it's the whole theme of that particular essay is being critical of the data. And there are other fun but insightful examples, including fish at a food store. Point is, be critical of the data, including and perhaps especially mapped data. And finally, explore the ArcGIS Living Atlas of the world and revisit it often, as remember, it's living and continually updated. I hope this discussion about data has been relevant, interesting, insightful, and I encourage you to teach about data, use data, be critical of data, and it's an exciting world. It really is. There's no shortage of data, but I think because of the volume, there are some concerns that we need to cultivate as we teach and do research and work with colleagues and students and others. Thanks for being with me.